And we're live. It's 2 o'clock, so it must be time for RockSim Live. I'm Tim Van Milligan. I'm your host. Thank you for joining us. This is where we talk about the RockSim software, RockSim, RockSim Pro, or the Launch Visualizer. We'll talk about all three of those today. And if you have any other rocket questions, we'll be happy to answer those as well. So today is, what is today? November 10. Tomorrow is Veterans Day here in the United States. So all of you that are veterans, thank you for your service. We're very happy to have you here. And we'll be happy to celebrate Veterans Day tomorrow with you. So where am I? So I am going to bring up my screen here. I have forgot to resize things before I started, so hopefully it will show up correctly when I click this button right here. My face is not showing up. Where is that one? This one. I gotta do a little bit of adjustment here. There we go. Oh, look at that, my head's cut off. Don't want to do that. There I am. Let's move this off to the corner. Okay, so hopefully that looks good now. We are live. I do have the chat running here on YouTube, so if you're brand new, say hello. I want to recognize you. We got a lot of visitors here. In fact, we got a new one that I have not seen before, and that is 462 Tool. And he is from North Dakota. We have Dennis Rainville from Connecticut. Happy Friday, Dennis. Thank you for joining us. Johan de Sloper from the Netherlands. Alfred Indy from Michigan. John Papp from Colorado Springs, so he's our neighbor. Thank you guys for coming. John Papp, says Alfred Indy, lives in the rocketry capital of the world. And that's true. It's the model rocket capital of the world. Yeah, Colorado is it, man. It's like here in Colorado Springs, because this is where Apogee is. And then like down the road, like 35 miles that way is Estes. And you know that they're a little company. They're struggling to do well like us. I don't know if they're struggling, but I'm just rubbing it in. They're great guys. Hi, Estes. You're my friends. And Dennis says today is the Marine Corps birthday, too. So, okay, all you Marines. My nephew was in the Marines, so thank you to the Marines. And Rick DeFossa is from New Hampshire is in the house. Cool. And yeah, so last week I was not here. I was in Texas. My daughter is going to the University of North Texas, and she's a athlete there, and so she had a diving meet, and so I got to go see that, and she did awesome. She's not watching this, so and she never watches, so I can rip on her. But she was ripping her dives. I mean, ripping means that's good. That's like going in without the splash. And when you rip a dive, just the bubbles, they just, and no splash on the outside. That's what you want. And she was doing pretty good. She didn't take first, but she finished about in the middle of the pack, but really good. Her dives are really coming along. So that's cool. Johan says it's 10 p.m. there in the Netherlands, so he's getting himself a beer. And John Eubanks from Mills, Texas. Thank you, John, for coming. And Wyatt May. This is not, this is unusual. We get so many new people the first time. So Wyatt, and he says my STEM class and I are here. So hi, STEM class people. We're glad you're here. Okay, so let's get started. And if new people come, I'm checking the chat. So if you have a question about RockSim, you can go ahead and put it in the chat. There have been a couple of chats already. Wyatt is from New London, Iowa. Okay, so we got somebody from the middle of the country here. Awesome. Yeah, so put it in the chats if you have a question. I do have a couple of people that have emailed some questions in, so I'll try to get to those as well. So if you've never seen RockSim before, if you go to apogeerockets.com, this is our homepage, and we got this scrolling banner bar here, and one of these is the launch visualizer, and one of them is RockSim. So here's RockSim, and this is version 10 that we are on, and working on version 11, and it's coming along. Maybe we might get to see some sneak peeks. If you scroll down further, we have the RockSim live training, which is right here. If you click on the image, it will take you to our archives. We are on episode 144. Today is November 10th, 2023. So in our archives, you'll see what we talked about before, and it gives you the link to YouTube so you can watch those, and it also gives you a timestamp so you don't have to watch the whole thing. So if you want to design a level 3 rocket, just go to 21 minutes and 16 seconds onto that video and you'll find it. So if you want to find a particular topic on this page, just do a Control F for find, or on the Mac it's Command F. It brings up a little search bar here, and you can do piston launcher. So that was one of the questions we had that came in via email, was how do you do a piston launcher? And it's been since episode number 42, so over 100 episodes ago. And yeah, 2 years since we last talked about that. So we could talk about it again. That's one of the questions that came up. Also, if you're on the Apogee website, if I go to here, and if I go to How To and Guides, click on that, and then come down here to Software. This is where you can download a free trial, you can purchase RockSim, you can find out what RockSim is. Frequently asked questions, there's video tutorials. Again, that RockSim live training link is right there, so you can get back there. There's multiple ways to find things on our website. Version history and system requirements are also there. So, let me see. John Papp says, can we talk rear eject and tube piston launch at some point if you have time? Okay. Tony Armit says, okay, just finished a week-long audit at work, just in time to join. So, cool, Tony. And John says he wants to talk about rear eject and tube piston launch, but not exactly RockSim. So this is general rocketry question. Okay, so this past week, we released a free plan on our newsletter. So if you go to How To and Guides, and then come down here to Peak of Flight newsletter, click on that, and so this gives you the latest issue. So in issue number 612, we had a plan for a rear eject Fat Man rocket. So if I click on that, it's going to download a PDF, and it's still downloading. And it's going to load it here in just a second. And so here's the PDF, and we want to get to the rear ejection plan. And I want to show you pictures, which is why I brought this up. So this is on page 6. And so this is what the rocket looks like. It looks like a bomb. Gives you all the parts lists for that item. And these are clickable links. So if you click on the part, it would take you to our website so you could order the parts if you want to get all the parts. And so basically, rear eject, it's pretty much built like a normal rocket. The only difference is the nose cone is glued on, but the engine mount is not. So your engine mount is free to come out this way from the rocket. And wish I had one with me. Oh, Kent, my phone is going off. I gotta call you later. Talk to you later. It's my other daughter. How come I can't turn there? Silent mode is on. Okay, so rear eject is built like a normal rocket. The difference is the engine mount tube and the centering rings are not glued into the rocket. So the centering rings are glued to the engine tube, but they're not glued in the rocket. So this is free to slide. And normally you want to make your engine tube long so that you basically you have to, let's see if I can zoom in on this without it destroying the quality. It's just slow to load. There we go. So there's some centering rings, and you need to have a front centering ring that's pretty far forward, and you're going to put your recovery device in the middle of these rings. And on this particular rocket, there's a streamer here that's taped to the tube and then just wound around the engine mount tube. So when the engine mount tube slides out, that streamer will be out. This centering ring here, the ejection charge goes through the tube, and then the nose cone is up here. And since the nose cone's glued on, the whole tube is going to slide out. And this ring prevents the ejection charge from getting to your recovery device. Now, if you have a parachute, it will still work. You just have to fold the parachute and wrap it around the tube so that it will slide in. As long as you can slide it into the tube, it's coming out. Just make sure your nose cone is glued on really tight. And then your nose cone is going to be your shock cord anchor. So that loop where you normally attach your shock cord or your parachute to on the nose cone, that's where you're going to attach one of the shock cord ends, and the other one you'll attach here to this ring so that the whole thing stays together, and it'll just pop right out. This particular plan, it just looks like a bomb, but here is, I wish I could, can I rotate this? Oh yeah, there we go. So here's that is not the engine mount tube. There's this tube here on the inside. So the inside rectangle, that's the tube that slides out. And here's one centering ring right there. There's another one. And then there's a third one up here. I would probably put it a little bit closer to the front. And the reason for that is that just gives you more room to wrap your parachute around. You got more volume because your parachute has to fit in this little container right there. But it can wrap all the way around the tube. So it's bigger than it looks, but there's still, you got to press it down and squeeze all the air out. This other tube is glued inside of this big tube, and it just makes it, because this has a boat tail, we want that whole tube to come out, and so it just slides through here. So that is rear ejection, and in RockSim, RockSim doesn't know where the glue joints are. There's no way to tell it. So when it runs a simulation, it just assumes that the parachute comes out. It doesn't matter which end the parachute comes out. Now the illustration in the launch visualizer shows the parachute coming out of the nose cone, but that's just because we don't know where you're planning on yours ejecting from. So we just assumed it's coming out the front. But when you run the simulation, just assume that the parachute is coming out the bottom instead of the top. Okay, so that is about rear ejection. And John says, thank you, I could not visualize it. And John says, what is the goal? What is the goal of rear ejection? Rear ejection, it has both positive and negative aspects to it. The positive aspect is you're not going to zipper a body tube, ever. Because normally a zippered body tube happens when the rocket's coming over the top and coming down, and then the nose cone comes off, and the nose cone comes back around the side of the rocket, and it digs into the tube. With rear eject, if the rocket's coming over the top and the parachute comes out, it just comes out the back. So there's no way for that shock cord to get wrapped over a lip. So you're never going to get a zippered tube. So that's the advantage. The disadvantage is, one we've already talked about. There's getting the parachute inside can be tricky because if, you know, depending on your design, you may not have a lot of room inside the rocket. So getting the parachute in there, inside that, around the tube is going to be a challenge. Streamers work really well. But the problem, if you're using a streamer, you're limited to a pretty lightweight rocket. The other disadvantage is that when they eject, when the motor comes out, they're known to be a little bit more powerful and more stressful on that shock cord. I've built a lot of rear ejection rockets, and they're more prone to separating in two parts than a regular rocket. So, and you know how easy it is for a regular rocket to separate. So just imagine a rear ejection, it's going to be more prone to separate. So you really need to make sure your anchor points, where the shock cord attaches to the nose cone and to that ring, are really strong. You know, so tug on them really hard before you launch the rocket, because for some reason, when that thing comes out, well, one reason is, if you look at this, we're pressurizing this small volume. Normally in a rocket, you know, the engine mount tube ends here, and so there's a bigger volume to pressurize. So it kind of, you know, you're taking the gas and you're going into a large volume, and so it's a little bit softer. Here we're confining all that ejection charge gas, and when we finally, it comes out, it's pressurizing this little sliver right there, and it hits it hard. And so it really kicks that engine mount out the back hard. So just make sure your shock cord is strong and your anchor points are strong. Lots of glue on that one. So that's one reason why you might choose to use a rear ejection. Okay, John says, fantastic explanation. And then 462 Tool says, can the heat from the motor damage the parachute? The answer is probably not. One is the rocket motor is going to be back here, because this is the back end of the rocket, and your parachute's going to be forward of that. So if there's any residual heat that makes it through the tube, it's not going to affect the parachute, because the parachute's further forward, and this front centering ring protects it from the ejection charge coming back. So the ejection charge is going to come through the tube, come outside around, come outside here, and then it's pushing on this ring. And if your parachute is wrapped around this area here, it's protected by that ring right there that's sliding out. And so until the parachute is all the way out, it's protected. Wrapping around a tube, even if the parachute was wrapped around right here, you know, you've picked up rocket motors after the flight, and the rocket motors are hot, but you can hold them in your hand. They're, you know, like a hot potato. They're hot, but they're not going to burn your hand hot. There's actually a manufacturing code in rocketry. In order for a rocket to be considered safe, the external temperature of the case after firing has to be, there's a threshold. And if it's above that threshold, it's not going to get safety certified. And it's because of this reason, so that if you pick up a motor after it's fired, you don't get an instant burn. It's going to be hot, and you're going to feel it, but it's not going to blister your hand. At least it shouldn't. So your parachute, even if it's plastic, can probably withstand significant amount of exposure to just, laying on the side of a rocket motor after it's fired. The heat propagation, particularly with paper motors like an Estes motor, heat propagation through the paper. Paper is an insulator. So the heat takes a long time to soak its way through the paper to get to the outside of the motor casing. So you're probably okay. Now where it gets really hot is reload motors, which are in an aluminum case. Aluminum is not an insulator. Aluminum transfers heat like nothing. So those get really hot really fast. So to keep the heat inside on an aluminum case, and you'll know this if you have a reload motor, is the propellant is inside of a paper tube. And that paper tube is the insulator between the propellant and the metal case. So the heat has to go through the paper before it gets to the metal case. And that's how come your casings, even though they're hot, they're still in that safe range where, yeah, you don't want to touch them, hold them too long, because, yeah, the longer you hold them, then you get a lot of heat. But you can, pick them up and drop them, and you can look at your hand and it's not burned. Yeah, so that's a good one. Okay, Wayne says, I emailed you a laser lock file that I created that would not launch in the program. They said it to forward it you for today's show. And I did get it, and let me take a sip of water and I'll open it up. Okay, so here's RockSim. I downloaded it, open downloads, and here's the laser lock. And I'll just open that up by just dragging and dropping it onto RockSim, and it says, do I want to save this current file? And I say no. Okay, so here's the laser lock file he sent me. So you can see up here at the top, it says laser lock. And I'm looking at the flight simulations, and there's no flight simulations in here. The rocket itself, just looking at it, just, a quick inspection, we can say it's 3.1 inches in diameter. It has a length of 73 inches. So this is a good sized rocket. And he says it's not flying. So let's try to load a motor in here and see what happens. So up here at the top is prepare for launch. That's where we're going to go to load engines. And we're going to choose an engine. It's 54 millimeters. I can see that right here. Choose an engine. And it doesn't matter which one I choose. So I'll just choose Aerotech 215 red line. And let's choose a probably 14-second delay. Engine overhang, I don't know. I usually typically use 0.5 inches, but this might have a retainer on the back, so it might be 0.25. And I'll click OK, and you can see it loaded the engine down here underneath my face. And here's the back of the rocket, and we're seeing the rocket engine. It's the brown thing right there. Okay, so flight events. Okay, so he's got 2 parachutes in here. And so basically I assume he wants to do dual deployment. But one of the issues is that I can't tell which one's the drogue chute and which one's the main chute. So at this point it doesn't matter because we want to just see if it launches. So I'm going to assume this top one is the drogue and the bottom one is the main. So I'm going to set this one to deploy at an altitude of 600 feet. And this is how you would set up dual deployment. Okay. Simulation controls, just leave it alone. Starting state. Okay, we got a 98-inch launch rod. So this is a big rocket, so it's a rail. And we're going to launch straight up. Launch conditions, altitude above sea level of 700 feet. And we have a wind of 8 miles an hour. And I click launch, and let's see what happens. Okay, so we get this one right here, that little icon. That icon means that the rocket didn't leave the pad. And you can see the maximum altitude is 0, optimal delay is 0. Okay, so this is a troubleshooting question. It's like, what happened? Why aren't we seeing this? So typically, if the rocket doesn't leave the pad, and we know it's a high power motor and it's got enough thrust, So one of the reasons a rocket might not leave the pad is you got a big rocket and a little teeny tiny motor, and the motor's just not strong. But this is a big motor. So this should easily lift this rocket. So it's not a motor problem. So that tells me, and this is from experience, that there's something wrong in the design. And looking at the parts, you know, you can't really tell by looking at them. You got to open them up. But we've seen this problem before, and typically it's either the nose cone or the fins. So I'm going to go down to, I'm going to start with the fins, and I'm going to open these up. And what I'm looking for is right here, the material. So you look right here, it says the material is custom. What is custom? Well, custom, I don't know. And RockSim doesn't either. RockSim doesn't know what custom material is because it's not in the database. And so we got to select a different material. So I'm going into the database. I'm going to choose plywood. And when we do that, I don't know if you saw that, but the fin set mass changed. Before it was a different value. Now it's 30.4 grams per fin, or a total of 91.224 grams for the entire set. So I'm going to do that. I'll click OK. And then what I'm going to do now is just rerun the simulation. So I didn't change anything except for the fin material. So I'm going to click on Launch up here. And you can see now it's running. And in fact, we get results, 2,942 feet. And if you look at the parachute icon, the rocket was coming over the top. That's what that arrow means inside the parachute. It means the direction the rocket was traveling right when the parachute opened. So that's the cause, is it's just a bad material selection. So how does that happen? How did that custom come up? And what I think happens is people are designing rockets so fast that they just don't check the materials, and it can sneak in there. If you don't choose a material, somehow it defaults to custom. And we've tried to find out how that happens, because this happens all the time. You're not the first person and you're not the last person that's going to have this issue. And so we don't know why it happens, but it defaults to custom, and that's what causes this problem where the rocket won't leave the pad. What we're trying to do to make it easier to find these problems is in the rocket design components here, I want to list the weight of each item, because if it's set to custom, the weight is going to be 0. In fact, I'm going to show you, give you a sneak preview of RockSim, the next version, and that's going to be RockSim Pro. As soon as it opens here, there we go. So I got RockSim and RockSim Pro both open at the same time. And I'm going to go back here and take that laser lock file, the same file, and then open it here in the RockSim Pro. And I'm going to go to the Rocket Design Components tab again to see, you know, the components. And so if you look at RockSim Pro, you can see that we're listing the weight of each of these items, because then you can go through your items and say, does that seem right? Should a nose cone weigh about 141 grams? Well, it's bigger than 0, so maybe. But if you come down here to the fin set, look at right here, 0 grams. So you're asking yourself, should my fins weigh 0? No, that can't be right. Fins should weigh something. So something's wrong with this component. So then I can open it up, and then I can see, oh, the material's wrong. That's why it weighs 0. So that's what we're trying to do to address this particular problem, is to list the weights next to the name. Yeah, so that's coming in the next version of RockSim and RockSim Pro. There's other things. You see this little button right here? This is a measuring button. So if I click on it, I can just click 2 points. So I got an X there and I got an X there, and it tells me the distance between these 2 points. 10.875 inches. If I want to measure the tube, I can just do a quick click. My line's not straight, but you get the idea. If I want to look at the base view. Oops, I didn't want that. I wanted the base view. In the base view, I can, what is the distance between my fins? I can click here to here. Oops, I missed it right there. That's because my drawing is so small and my mouse is so big, I'm not clicking where I want to click. So that's another new feature that's coming. I could show you more, but I got other questions. So let me hide that. Okay, so that was the laser lock question. And then I had another question from another person that had a rocket and he was trying to do dual deployment and his wasn't working. So let me bring that up. And okay, so save to downloads. Okay, so another person sent me this rocket called an EAC Viper 4X. And do I want to save that one? Say no. Okay, so here's the Viper, and I think this is an old Estes kit, Estes Aerospace Club from a long time ago. This might be in the 1970s. They had a Viper, and he 4X'd it. So it's now 4 inches in diameter. And his question was, how do you do dual deployment? He couldn't figure out how to do dual deployment. So if I go to simulations, so this is another troubleshooting tutorial. So he says it doesn't do dual deployment. So how can I, as an outside observer, verify that he's not seeing dual deployment or something's wrong? So here's what you do. So the one thing is you have to select the simulation that he's already ran. So I'm going to select, I try to select the last one because obviously, he's had the problem a number of times. And so he says, this is the last one that I ran. It's simulation number 8. So I'm going to open that. But I'm going to open it a special way. So I'm going to right click on it with my mouse. And instead of load engines, I'm going to choose edit. And so what this does is it loads the engine, but it also loads everything that he set. So if he set a wind speed and an altitude and a launch angle and all that other stuff, I'm going to see it just by going along these tabs right here. So first it loaded that Aerotech J615ST-11. And then if I go to flight events, okay, so now I'm looking at his parachutes. Okay, so he has this parachute, the drogue parachute, set to deploy at Apogee, and he has his main parachute set to deploy at 600 feet. And this is the correct way to set up dual deployment. So I'm already thinking, if it's not working, something is really wrong. Because normally, this is where it happens, right here, is where how you set up the flight events as you're running your simulation. So starting state, he's got a 96-inch launch rod. Launch conditions, it looks like he's set this up pretty much how I set things up. These are like the default settings. And let's click Flight Profile and see what happens. Okay, so we got the same results. So I was watching that number as it was running the simulation. So it reran the simulation and it gave me the exact same results. So that's a good thing to see right there. So here's the rocket sitting on the pad, and let's click on, let me see if you're getting what I'm seeing here. I got to move this screen up just a little bit. Okay, so you can see all the buttons. Okay, so I'm going to click here, which is the play button, and it's going to animate the rocket. So the rocket took off, and this is where it was making thrust, because you got smoke, and smoke is drifting with the wind. The rocket's coasting upwards, and at Apogee, yeah, there's a parachute. That's good. That's the drogue parachute. And the rocket's coming down, and you can see it's coming down pretty fast. We got a long way to go, though, but he's got it set. We got it set to deploy. What did we say it was? I can't remember. It was 600 feet? Anyway, we'll wait. So the rocket's coming down, and I'm looking at all these dots. Now, these dots are 1 second apart. And I'm looking at them, and all the dots coming down are about the same space, except for all of a sudden right now, it changed. And this is a characteristic of a dual deployment rocket, where something happened right here at this point, where the rocket was coming down at a constant speed, and all of a sudden it slowed down because the dots got closer together, which means that they were at 1 second apart. The rocket didn't move very far. That's why they're closer together. So this tells me that something happened. Now the image looks identical, and this is probably what he is confused about, is in this image, in the animation, the image of the rocket doesn't change. And this is a characteristic of RockSim. RockSim is 20 years old, and is it 20 years old? Nah, maybe not quite. But the old technology was this. The animation is created using something called sprites, and this sprite, we can't change that image when a new parachute comes out, unless it's a two-stage rocket, because then it's different. But what happened is, I would say, yes, your dual deployment is working. You have it set up correctly. It's just that it's just an interpretation of the 2D flight profile. So I'm going to cancel that. Now I'm going to show you what it looks like in RockSim Pro. So here's RockSim Pro again. And I'm going to clear out this design. And then I'm going to open that design, the Viper, in this program. Okay, so here's RockSim Pro, and we're going to run that same simulation, and I can do it over here as well. So I'm going to go to the simulation tab, find that simulation that he ran. So it's kind of like I'm starting all over. I didn't do anything because I'm in a new program. And I just opened the file, and I'm going to do a right click on that simulation and choose Edit. And it loaded the engine, it loaded the starting state, it loaded the launch conditions, it loaded the flight events. Now the flight events, let me stretch this out. Now it didn't load the flight events. Okay, because RockSim Pro runs flight events different from RockSim. So RockSim Pro is different from RockSim in the flight events. I should have done this in the launch visualizer, because the launch visualizer uses the same flight events as RockSim. Anyway, so he's got the main parachute and the drogue parachute. So we'll set the drogue parachute to deploy at Apogee. That's normal. But the main parachute, the difference in RockSim and RockSim Pro is RockSim Pro can actually deploy the parachute on the way up while the motor is burning, where RockSim can't. So you have more options on how to deploy the parachute. So you have to set up like you're coding, like there's certain conditions that have to happen. So the first condition for a dual deployment is the rocket has to reach Apogee and then be coming down. So there's two conditions. It's got to go up and come down. We don't want to just deploy at an altitude, because what's going to happen is, as the rocket's going up, and it hits that altitude, it said, hey, just deploy. But, so that's why we have to set a couple of conditions in RockSim Pro. This is only for RockSim Pro. So we have to set, the first condition is it has to reach apogee. So it has to get to the top. And now I need to add a next condition. And so the next condition is as it's coming back down, it's got to reach a certain altitude. So here's where you add an event. So I'm going to click the little plus sign and I get another row. And now I'm going to add my second condition. It's got to reach an altitude. And then here's the other thing. You have a test. There's a greater altitude or a less. Say I wanted to deploy at 600 feet. So I'll type in 600 feet. So the way I have it now is it will deploy if the altitude is greater than 600 feet. Well, that's not what we want, because if it's at apogee and the apogee is above 600 feet, it's going to deploy right at apogee because it's greater than 600 feet. You know, it's the first number it's going to see is greater than 600. So we got to change this to less than 600 feet. So then it's coming down, and as soon as it's less than 600 feet, now I want my parachute to come out. So this is how you set up dual deployment in RockSim Pro. And now when we go to the flight profile, now this is the other big difference, is our animation is completely different. In RockSim Pro, we've instead of being a 2D simulation, it's actually a 3D simulation, and it's still loading. Okay, here it comes. Okay. So it's drawing the rocket, and you can see there's a blue background. And the reason is because where we're launching from. We're actually launching, if I scroll out far enough, you'll see where we're launching from. This is the globe, and we were launching from right in there. So let me swing it around so north is up. And so we're launching from right about there. So let me zoom back in. Home. So we're in the water, and that's why you're seeing a blue background. But regardless, the rocket is on the ground, and if we launch it, the rocket takes off. You see the smoke and fire come out. The rocket's going up in the air. We're at 2,000 feet. All this in the background is still water. Not a lot to see when you're in water. Okay, so then we hit apogee, and the main parachute came out. The rocket is coming down. You can see it's moving around a little bit. It's still coming down. You can see the altitude right here. We have this set at 600 feet. So I'm going to zoom out just a little bit. And it's coming down. We're still at 1,200 feet. It's still coming down. Not a lot to see in the background because we're in water. 700 feet. 600 feet. Boom! You see that change? Something changed. We got a bigger parachute. And that's what you expect to see, is your big parachute to come out because it is dual deploy. And I'm going to bring it all the way back down to the water. And let me zoom out. Okay, so there's nothing to see here because all this is water. So let's run the simulation and choose a different launch site. That's the other difference in RockSim Pro, is you got to pick a launch site that's on the planet or that's not in the water, because that's no fun. So that is under the Launch Conditions tab, and you can choose a launch site. And I have one that's already loaded in here. This is in Colorado. And if I hit, let's see, what do we have for wind? 5 miles an hour. Let's make it 9 miles an hour. Yeah, hit flight profile. So I want the rocket to drift a little bit, so it doesn't look like it's coming straight down. Okay, so it's rerunning the simulation, and then it's going to reload. And you can see our altitude went up a little bit. And the reason for that is that now we're launching from Colorado, so our base elevation is higher and the air is thinner. And if the air is thinner, the rocket's going to go higher because the drag is lower. All right, so now if I zoom out, now we can see some terrain in the background. You can see, we got some mountains over here. And it is a full three-dimensional launch environment. And if I launch, my launch site is right there where my cursor is. I'm going to zoom in a little bit. And then I can tilt it a little bit. See, my rocket is right there. There's just a little tiny green dot. And if I launch it, the rocket's going to take off. You can see the smoke coming out. This green is the trail of the rocket, the trajectory. This blue line right here is just the smoke drifting in the wind. And we're going to hit Apogee pretty close now. You can kind of tell that. And there's the Apogee point. And now the rocket is coming down. You can see this green line here is the downward trajectory. And we're at 2,000 feet. It's still coming down. These red lines right here are just kind of like drawing from the trajectory down to the ground. And you'll see it when we get down to the ground. That way you can kind of see the ground path of the rocket. And see, it's right here. So we've got a little puddle right there. We're going to miss that puddle, I believe. Oh, okay, so right there, let me pause it. You can see the rocket was coming down at this rate, and then all of a sudden it took a dog leg. And this is just like what we saw in RockSim on the 2D flight profile. You always look for that dog leg right there to verify that dual deployment has worked. And, continue it, and it'll probably land somewhere over here in this grass. It's a good flight. I'm going to get my rocket back. Okay, so that's rocket landed. It landed about 975 feet away. So I can zoom out. And you can kind of get the trajectory of the rocket, looking at it from different angles. Our launch point, again, was right there. Rocket took off. It went up. Apogee point is the green dot here at the top. Green dot is good. That means that it was inside our imaginary cone that is 30 degrees from the launch site. We want that to happen because that means the rocket is going more vertical than horizontal. So it's always safer to go up than to go sideways. All right, so that's looks pretty good. All right, so that's dual deployment, and I'm pretty sure that's the issue that he was seeing. He had it set up right. It was just a matter of interpreting the 2D flight profile, just what were you seeing there. Wyatt says, do we get a free upgrade like from version 9 to version 10, or there will be an upgrade fee for Pro? Okay, so RockSim Pro is already out. We're going to release a new version of RockSim Pro. So it's kind of like going from 9 to 10 to 11 in RockSim. But in RockSim Pro, we're currently on version 3, and we're going to release version 4. RockSim Pro is priced different from RockSim. RockSim is a one-time fee. And so when we had version 9, we gave everybody a free upgrade to version 10. RockSim Pro is a subscription-based model, so there's a fee per month to use it. And the reason for that was all those images that you saw in the graph, in the trajectory. I have to pay for those every time somebody uses them. So because of that, I got to make it into a subscription software. Where RockSim, it doesn't matter. So RockSim Pro, the price is lower, but you pay it every month. Currently, it's $30 a month. If you want something similar, you can go to the Launch Visualizer, and Launch Visualizer is just $3 a month right now. When we release the next version of RockSim Pro, I think I'm going to change the prices and make the prices a little bit less, because now that we've had RockSim Pro out a while, I know what my expenses are for all the maps, so I can price it so that more people can use it and still make profit or not lose money. Right now I'm losing money, but that's because we just don't have enough users. So what we want to do, what I'm thinking about, is making it similar to the launch visualizer, where the fee is really low, and then you pay by the month and you get all the features. The difference between RockSim Pro and the launch visualizer is RockSim Pro runs on your computer, where the launch visualizer runs in the cloud. And the other big difference is in RockSim Pro you can design rockets, but in the launch visualizer you can't. You can only simulate rockets. So I can take this Estes Viper 4X upscale, and I can go to open up a new browser. Where's my browser? New window. And I go to rocksim.com. This is the launch visualizer. And just wait for it to load here, because this has to be in the cloud. And then, come on, finish loading. Then you have to log in. And here is me. I'll log in. Okay, so now I'm logged in. So my login button went away. And I'm going to upload that design. And I'm going to browse on my computer. Come on, wake up. And then we go to, it was in my downloads folder. EAC 4X upscale, click open. And upload. And it's uploading the design from my computer up into the cloud, which is wherever the server is. Okay, so it uploaded it, and it will redraw it here, and that will confirm that I've uploaded it. Come on, wake up. It's thinking. There we go, it's starting. Okay, so it drew the rocket on the pad, and then our simulations are, now we can run a simulation, but I can't edit the design. So if I wanted to run this simulation, first you choose a launch site. I'm going to choose one from the database, and it will load the database here in a second. And I'll choose that one. I think this is similar to what I was just launching at. And it will redraw the launch pad in the new location. That red dot right there is the launch pad. And it's still loading the maps. It's still taking a while. I can see the mountains, but I'm not getting that. It hasn't painted the terrain on the mountains yet. It's just taking a little long time. And I'm not sure why that's happening. If you have fast internet, it should be pretty quick. But then, when you're ready to launch, you can choose your starting state, launching straight up, and our, oops, that's rocket motors. Have a wind, steady wind, I think, what do we say, 9 miles an hour. Click OK. Load the rocket motors. I think we had, what, we have a J615. just acting a little slow. J, I can search for it. J615. There it is. And select my delay, just like in RockSim. I'll make it 15-second delay. Use that. Engine overhang, what do we say, 0.5 or 0.25? Doesn't matter. Okay, and then launch. So you can run this same simulation just like we did in RockSim Pro. Although I didn't select the flight events. But the flight events are just like in RockSim, where you don't have to set conditions, because we realized that a lot of people found that too confusing. So in the launch visualizer, we just eliminated that. It's trying to paint the ground. Come on, maps. It's just taking forever to load those maps. But if you launch it, I can still launch it without the maps behind. Rocket's taken off. Now it's coasting. We changed the color of the smoke for coasting to blue, so you could tell thrust smoke from coasting smoke. And it's still coasting up. It's going a little slow. It's not quite real time. Trying to speed it along here by moving the slider bar. So there's the first parachute, and there's the second parachute, and I can have the trajectory path, so just like it's in RockSim Pro, extruded to the ground. Click OK, and I can see if I zoom out. Come on, zoom out. This is very similar to what we saw in RockSim Pro, except for the maps aren't being laid over the terrain. And I didn't set, like I said, I didn't set my events. So it looks like we just have one parachute deploying because I don't have a different dog leg. So here's Apogee. The rocket was coming over the top and ejected on the way down, and just one parachute and no dog leg coming out to the side. So that's the launch visualizer, and that's the difference. And so we're just trying to get more people to use either RockSim Pro or the launch visualizer, because it's just going to make dual deployment easier to interpret, because you can actually see things happening. Dennis asks, how do I tell RockSim to not recommend engines that are too long for my engine thrust rig? Well, so what he's talking about, so see on this engine, the engine only goes this far, but there are really long engines. Let's see if I'm in RockSim, yeah. So if I go here, and if I go choose an engine, and what I'm looking for is the length. So this motor, the J615, is 9 inches long. If I sort by length, and if I scroll down to the bottom, okay, so here I have a 26-inch long rocket. And I click OK. You can see my motor tube ends right there, but the engine extends a little bit further. So his question is, how do I prevent RockSim from picking motors that go too far? And the answer is, you can't. RockSim looks at the diameter. It doesn't look at the length. To figure out the maximum length, it takes artificial intelligence, and RockSim doesn't have artificial intelligence. So basically you have to look at it and see if it's hanging too far forward, that could be a problem, or sometimes it doesn't matter. On this particular rocket, it probably doesn't matter because my next bulkhead or object is this tube coupler right here. There's probably a bulkhead right here, and this engine doesn't hit it. Now this gray rectangle, or this rectangle right here, is probably a parachute. So if I go to Rock Designs, and if I go to my parachutes, so yeah, that's the drogue parachute right there. So I could wrap the parachute around the outside of the motor, and we talked about this a little earlier today, is yes, you can wrap the parachute around the motor, and it's not typically going to harm the parachute just from the residual heat of the motor, because there's a standard that says that the outside surface temperature within a number of seconds after engine burnout has to be a certain value, and it can't be above that. Aerotech had a problem with motors that were really long duration burns. You know, they were having some problems with motors that were like 13-second burn time. And what would happen is, because they burn so long, that the heat can propagate through the casing to the outside, where it might touch like a parachute and then get it really, really hot because it's burning so long. So normally, the flight of a rocket happens pretty quick. You know, even if you use the maximum ejection delay of that motor, and that motor is probably like a 20-second delay. The maximum was 11. So that's pretty fast. You know, it gives you time to get the parachute not only outside of the rocket, but deployed before the casing would get too hot. So you can wrap motors around the outside, but if there's something in the way, you know, if you do put an engine block in there, that's going to prevent it from going in, and then it's going to hang out the back, and that's a problem, because that's going to throw off your center of gravity, because this is your center of gravity right there, that dot. And if the motor's hanging out the back, and I can show you what that looks like just by going to the engine overhang. Let's say I hang it out the back 8 inches. And didn't hang out the back. Let's try that again. Engine overhang. 8 inches. And I got to resize this window because my buttons went away. This is a problem we discovered on the newest version of Mac OS, is some of our screens kind of disappear. I'm running OS Simona 10.14. Okay, so here's where the rocket hangs back, you know, 8 inches, and we're still hanging out the front, and our center of gravity moved back. So we got to watch that, make sure that that center of gravity doesn't get behind the center of pressure, because the rocket could go unstable. That's the definition of an unstable rocket, so we don't want to do that. So you definitely don't want to have your rocket hanging out the back too far. You can get away with a little bit, but don't let it hang out too far. So I'm sorry that there is no way to tell RockSim. It's kind of like telling RockSim which direction the parachute's going to come out. Is it going to come out the front, or is it going to come out the back? It's not smart enough to know. Tony says, can you short engines by length? I think he's saying, can you sort engines by length? And the answer to that is yes. So if you open up your engine database by double-clicking, so this is the database, and you can see you can sort these columns just by clicking on them. So right now they're sorted from smallest or shortest, which is at the top. So my shortest one is a Cesaroni, and it's 2.71 inches long. And my longest one, if I go down to the bottom, well, This is obviously wrong. 255 inches, yeah, that's wrong. But this one right here is 26 inches. So my guess is the decimal point is in the wrong place on this one. And this one that says unknown, I don't know what that is. That's probably some motor that I made up for some reason. I'm constantly making motors just for fun. Just for a RockSim, I mean. Yeah, he's just hoping that there was an easier way. Yeah, I'm sorry. Okay, I'm looking to see if there's any other questions here. I think that's all of them. Yeah, I think I got them all. So, I think we're done for the day. It's after 3 o'clock. So we'll go to that screen there. So there I am. So yeah, we will be back next week, Friday. So today is the 10th, so that will be the 17th. But then the following Friday is the day after Thanksgiving here in the United States. So we're off Thanksgiving Day. We're going to have a smaller crew here on Friday. And because of that, I'm probably going to not be able to do RockSim Live. And I think there's all kinds of fun things going on TV on the day after. That's Black Friday. We will be here for Black Friday. But because of that, I probably won't be doing the live presentation on that Friday. So we will be here. So if you have a question, you can still call us up and ask on the phone. And our website has a contact form, and it has our phone number right there, and you can call. And we do answer our phones with a real person, not with voicemail, with a real person. This is something that, you know, your time is valuable, so you don't need to be wasting it listening through a menu of options in order to get to a real person. So we do answer our phones. All right, so thank you for being here, and we're gonna go out with a launch. So in 5, 4, 3, 2, 1, go out and launch something.